So one of the more difficult things to conceptualize is how your map is being distorted when you change projections, right? So each projection that you use, it preserves certain elements, distorts other elements, right? Sometimes we use a compromise projection, which minimizes the distortion on all these different categories, but allows a little bit of distortion in each of them. Other maps, like the Mercator, preserves angle at the expense of other aspects like shape or scale. So, each different projection that we use, there's a level of distortion, and it can be hard to conceptualize what that distortion is. And so there's some tools that are kind of interesting, can help you think about that. So one is the Tissot indicatrix. This is developed by a French mathematician in the 19th century, and essentially what this does is puts ellipsoids on your map, and then as you change the projection, those ellipsoids shrink or grow or get squashed or change shape. And that allows you to see how that distortion is changing this kind of similarly sized or consistently sized piece. With country land masses, it can be a little more difficult since they're irregularly shaped. They're positioned in certain ways that you're used to seeing, so it can be hard to see how the distortion really is playing out. Whereas if you just throw some circles on there and then change your map projection, you can get a better sense of like what exactly is being distorted, what exactly is being preserved, and in which ways. So that's one option. You can do this in ArcGIS Pro. There's a tool in the toolbox called Tissot, and you just pop that in. It'll generate this, and you can play around with it. There's also Getemin profiles. This was developed by a Soviet cartographer in the 20th century. And in this case, he put these kind of like grotesque looking faces on the map. And then as the map projection changed, and those faces distorted and became kind of uncomfortable to look at. And in that way, you can see the distortion in a different way, right? So there's a web tool that does this. It's kind of cool to look at. You can basically pick different projections. Let's just go to Mercator to start, because that's one that we're fairly accustomed to looking at. Right, and this has our Tissot in there. We can see as the map moves, we can see different elements of it, how things are distorted in different ways. Now we can throw these faces on here too. Right, become even more unsettled as we do so. Let me pause this as well. So here we're looking at it from, let's put it at like a, there we go. Puts us at our fairly, how we're fairly used to seeing the Mercator map, and we see these faces are distorted in these weird ways. We could shift to, let's say, like a more compromised projection, like the Robinson, right? And again, we can see that this combination of the Tissot along with these faces allow us to see distortion in some different ways. We can unpause this, let it go weird on us. So, a good way to kind of look at different projections. A lot of these are kind of named after mathematicians and cartographers from years and years ago. So sometimes it can be kind of hard to like remember which ones do what. So, a visual demonstration can kind of help conceptualize that a little bit more. Okay, so that's like a visual index that can help see different types of projection distortions. And then we have here a parallel coordinate plot that essentially does the same thing, but gives you a little bit more kind of mathematical underlying evaluations of distortion. So in this one, we can let's go again to the Mercator since we're used to looking at that one. Right, and there's various different scales here. This scale here on the left, or the first one, the accuracy 40%, 150, that's basically just an overall projection distortion measurement. Scale is basically your distance between land masses, area is the size of land masses, and angle is the shape of the world. So, in the Mercator projection, for instance, overall, it's a pretty highly distorted map. It's very highly distorted on its scale and its area, right? Depiction of land masses and the distance of land masses from each other. But the angles are preserved, right? This is, again, the purpose of the Mercator map was to be able to draw a bearing on the map and then follow that bearing in a ship to navigate the ocean. Whereas if we go to, let's go to a equal area projection here, right? This one is a little bit less overall distortion, right? Very highly distorted on scale, but the area is completely preserved, right? Going all the way down to 0, and then the angle is distorted. And let's go to a compromise. The Robinson projection is a compromise projection, right? This one kind of tries to strive for a little bit of distortion in each of these different categories, but to keep it as low as possible. Let's find another. And here, so you can go through, you can get, a visual look of what your global projection is, and also the distortion along that goes with it along these different categories. So another way you can kind of think about how the choice in projection you're making has implications of how your map looks, right? And that's kind of easy to conceptualize on a global scale. It becomes a little bit more difficult at different scales, like if you're doing a continent or a country. Sometimes that can make things easier because distortion won't matter as much with small areas. Sometimes it can make it more difficult. So there's a lot of different factors. But having some of these tools that allow you to see how things are distorted and compare them to each other can be incredibly helpful.